Okay, we're going to go over our last conic, the parabola conics, and this is the third and last one of this unit. And as far as the parabola conics, I find that students tend to find this one the easiest to work with. There are a lot more moving parts, but as the overall approach to graphing parabolas rather comes easier. So let us dive in and see what that's going to look like, okay? So what are all the parts to a parabola and how do you graph a parabola? Well, here we're going to begin with the definition of a parabola. A parabola is the set of all points, x and y in a plane, that are equidistant. So let's go ahead and write that word down. Forgot how to spell that for a second. Equidistant from a fixed line, which we are going to call the directrix, and a fixed point called the focus. The midpoint of the segment from the focus perpendicular to the directrix is called the vertex. The line that passes through the focus and the vertex is called the axis of symmetry. Now, as we've done before, many of these terms probably are not going to really hit home until you actually do some graphing. But here are the two of four examples of what our parabolas can look like. So on the left-hand side, we have the vertical parabola where it's pointing upward, but just know that our graphs can point either upward or downward. On the right-hand side, we have the horizontal parabola that will point either left or right. So unlike the hyperbola where we have two U-shaped graphs occurring at the same time, pointing in opposite directions, parabolas are single U-shaped graphs. As I scroll down below, you are going to come across, on your note-taking guide as well, a chart just as we've done before, but I've highlighted where I want your attention to be focused on. Notice that in both of these equations, that compared to the other two equations of ellipses and hyperbolas, we notice a difference in that parabolas only have one squared term. Okay, with ellipses we had two squared terms that we're adding. Hyperbolas we had two squared terms that we're subtracting, but with parabolas, notice we only have one squared term. One thing I want you to recognize too is when a parabola is horizontal or vertical. When the x is being squared, so right here where the x term is being squared, notice that our graph is going to open upward or downward. So in this scenario, our parabola would have a vertical orientation, whereas if the y quantity is being squared, it's going to be a horizontal facing parabola. In other words, the parabola is going to either open right or left. How that's determined, right or left, is determined by the p-value, and I will introduce what that p-value is in the following example. Okay, so let's see if there's anything else here I need to talk about. Oh yeah, here with our vertex, I do want you to notice that it's still going to come from taking the opposite value in our parentheses. Okay, I do need you to pay close attention to the fact that sometimes our x's and y's do interchange. So what do I mean by that? I'm going to highlight in pink here what I'm talking about. Notice here the x is mentioned first, then the y is mentioned second, but over here, let's do it in green or purple. The x is mentioned here first, second, and then the y is mentioned second. So make sure you keep the order correct when you are putting them into coordinate form. X always comes before y. Okay, so let's go do an example. You're going to notice in your note-taking guide that you have 4 examples, but I am going to only cover 2 examples with you. So flip to the other side, and we're going to do example 3 and number 4 together. Okay? Now, when I am doing example number 3, bear with me because I'm going to give you a lot of little notes within that problem just to guide you as you do your homework. But of course, all these little notes that I provide you with, that's not required when you're doing your homework, okay? So let's start here. Our equation is x minus 2 squared equals 12 times y minus 1. So the first thing I want us to do is to determine what the orientation is. So I'm going to put the word or the number here first because I want to make a statement that the orientation is the first thing you should focus on getting done. Whoa, I don't know what happened there. I think it made it, maybe thought I was doing a triangle. So the first thing you're going to do is your orientation. So we need to determine, is it opening up or down or right or left? Well, we notice here that the x term is the one being squared. So if we go back up to our chart over here, when our x is being squared, we notice that it was a vertical parabola, so it meant that it's going to be opening either up or down. So I'm going to choose down here up or down because I'm not sure which one as yet, but I know it's definitely going to be a vertical pointing parabola. Okay? To determine whether it's up or down, you are going to use the p-value. The p-value can be found by finding the coefficient of the non-squared factor. The coefficient of the non-squared factor is always going to be the number with the factor without the little 2 exponent. Okay, and that number in this case is a 12. If you look at our chart again, the coefficient of the non-squared factor is equal to the quantity 4 times p. Okay, 4 times p. And that p represents a distance in our graph, and I'll show you what that p distance is. But let's calculate what 4p is. So you will take the formula of 4p and set it equal to the quantity, the coefficient of your non-squared factor, and in this case it's a 12. I'm going to solve for p by dividing by 4 on both sides, and p equals 3. Now, because our 3 is a positive value, in other words, it's greater than 0, that means that we are going to choose an upward facing graph. Again, why? Because my p was greater than 0. It was positive. So that helps us determine up, down, right, or left. If it's negative, you would say down. If our graph was pointing right or left, p-value positive is right, p-value negative is left, just for future reference, by the way. So that's my p-value. So that's the next thing you would do to help you determine the orientation. The second step you are going to do is find the vertex, and you won't have any problems with this because you've been doing it all along with ellipses and hyperbolas. You take the opposite value of the x and y factors. So the x minus 2 factor comes first because it's x, so that's going to be a positive 2, and then the y minus 1 is going to be a positive 1. So I'm going to go plot my vertex immediately, and so I'm going to go over to my coordinate plane, go to the right 2, up 1, and I'm going to put this dot here to represent my vertex. I know that my graph is going to be pointing upward, so I know that my graph is going to do something like this, or maybe like this, or maybe like this. I don't know. It's pointing upward. I don't know how wide my graph is going to be, but I keep that in mind, okay? And if you want to, just you can make a little note to yourself over here under example 3 and say, hey, you know it's going to be pointing upward. After the vertex, you are going to find the focus. So I'm going to put this as your third step. To find the focus, here's what I want you to do. And here's where my little notations come into play. I want you to use your orientation and your p-value to help you plot your focus. Okay, so you're going to see what p-value means here. Our orientation was the word up, and the p-value was 3. So I am going to go up 3. Where? Always from your vertex, okay? You're always going to do it from your vertex. So if I go to my vertex and I go up 3, 1, 2, 3, my dot will be right here. And I'm going to give the labeled point. In that case, it's going to be 2, 4. So I'm going to come over here and write my answer to focus is 2, 4. It's a point. So this is your P distance right here. P is the distance from your vertex to your focus and from your vertex to your directrix. But I'm going to stall on that for a second. I'll talk to you about that in a second. Okay. Now, the fourth step is going to be your, what is it? Should I do? Let's do the fourth step being axis of symmetry. And by the way, you don't have to do it in this order. Oh my goodness, there's that triangle again. I just find that when you do it in this order, it seems a little bit easier. So here we go. The fourth step is your axis of symmetry. The axis of symmetry, let's do this in like a bright pink, is going to be a dashed line, okay, that goes through your vertex and your focus. Okay, so I'm putting that as your fourth step because you just graphed your vertex and you just graphed your focus. Okay, and the dashed line is going to go through those 2 points. So we're going to come over here with a straight edge and let us draw this dashed line that goes through these 2 points. And you're going to put arrows at the end. And this axis of symmetry, if I can get this ruler to work with me, this axis of symmetry splits your parabola down the middle, so that if you were to fold this parabola on this axis of symmetry, all points on the left-hand side of this axis of symmetry would fold over to the right-hand side. So this is your axis of symmetry, and I'm going to label it AOS over here. See if I can do this. AOS, just to remind you that that's our axis of symmetry equation. Now, how do you label or how do you identify in equation form what the axis of symmetry is? Well, notice the axis of symmetry here goes through our x-axis at what value? At 2. So I'm going to say x equals 2 is my axis of symmetry. You will always give it to me in equation form. The next step, the fifth step, is going to be our directrix. The directrix is also a dashed line. Okay, so I'm going to put here dashed line, but this time this dashed line is going to be perpendicular to axis of symmetry. So it has to form a 90-degree angle. Okay, the dashed line is going to be drawn by doing the opposite of what you did on the focus. Okay, so you're gonna, whoops, sorry about that. Sorry, my thing's shifting here. Give me a second. There we go. You are going to, oh my goodness. Hold on, I think my computer is kind of freezing up on me here. Okay, back to doing this. Directrix is going to be a dashed line perpendicular to your axis of symmetry. What you're going to do is do the opposite of what you did to find focus. Oops. Yeah. To find your focus. Okay. So in our case, we did up 3 to find the focus. So we are going to go down 3. Okay. And if I go down 3 from my vertex, okay, 1, 2, 3, another P distance, I am going to draw a perpendicular line to my axis of symmetry. And I'm also going to use a dashed line okay. I'm going to put my arrows at the end. Okay, again, notice here that's a 90-degree angle, all right? And the P distance from focus to vertex and from vertex to directrix has to be equal. Both of those had to be P distance of 3. And I'm going to label this DIR for notes so that we know that this was our directrix. Directrix is also going to be an equation for a line, and since it's perpendicular, we know it can't be an x equals because axis of symmetry was x equals 2. The directrix is going through the y-axis. So y equals, it's going through the -2 value, so -2 is my directrix. Okay, so just to highlight my answers thus far, just because I have so much written down, vertex was a 2, 1. Focus was a 2, 4. Axis symmetry, x equals 2. And directrix is y equals 2. And then, of course, our p-value. Everything else is just notes to help you understand what we did in this particular problem. Now, you remember I told you guys that this graph is going to be facing upwards, and we knew that it was going to look something like this, a U-shaped graph facing upward, but we have no idea how wide it is. So what we need to do is we need to still find 2 points. So I'm going to put here, we need to find 2 points for the width of our parabola. Okay, and it's really easy to find these 2 points. What I want you to do is I want you to focus on the word 2 points. Notice I'm writing 2 points up here and I'm highlighting something particular. I'm highlighting 2 and the letter P of points. That actually is the formula that I want you to use, 2 times P. That's the distance that you are going to calculate. In our problem, it's going to be 2 times 3, and we're going to get a 6. That distance has to be counted from the focus at all times. Okay, you won't count from the vertex like you've done with others. You're going to count from the focus. Since it was an upward facing graph, right? I know that I'm going to put points on this side and on this side of my parabola. Okay, so let me erase that chicken scratch there. So here's what I mean. From the focus, I'm going to count to the 6 to the left, 1, 2, 3, 4, 5, 6, and put a dot. And then I'm going to count to the 6 to the right, 1, 2, 3, 4, 5, 6. Let me move this down a little bit because it's not letting me. Around right here. And now I have established how wide my U-shaped graph is going to be. So from the vertex, I'm going to graph towards the point on either side. And there is my parabola. So notice how I'm trying to make it as symmetrical as possible, but I'm failing. There we go. So there is my parabola. Okay? Upward facing, and I know my width based on the distance 6 that I traveled from here to here and from here to here. That was the distance 6. Okay? All right. So let's do this last problem without having to write all the details that we just did in this problem. Okay? So you could see that it's pretty straightforward. So for this purpose, notice that the y is being squared. Okay, so since the y is being squared, we know it's going to be a horizontal facing graph. So I'm going to put horizontal. Okay, and we have to determine if it's right or left. So what are we going to do? Well, we're going to go and find our coefficient, and we're going to set that coefficient equal to 4p. So 4 times p has to equal that 10. And when I divide by 4 to solve for my p, 10 divided by 4 is going to give me a 2.5. And this p-value is greater than 0. Because it's greater than 0 and it's positive, I know I'm going to be drawing a right-facing parabola. So under example 4, I'm going to give myself a little reminder that I'm doing a parabola that's pointing to the right. So let's get started with the graphing, starting off first with our vertex. The vertex is x, y. Here's my x. My x is not adding or subtracting with any number, so I'm going to put a 0. Then my y is not adding or subtracting with any number, so I'm going to put another 0. I'm going to go plot that point at 0, 0, and that's going to be my vertex. Now remember, I'm going to be pointing towards the right, so I know it's going to point that way. I just don't know how wide that right parabola is going to be. After the after the vertex, I'm going to graph the focus. The focus depends on the orientation and the p-value. Notice I said right, and my p-value was 2.5. So I need to go to the right 2.5, okay? I don't have to write that down. I'm just writing it down so that you can visually see what we're doing. So right 2.5 is going to be right about right here. And I'm going to label it F for focus. So what are the coordinates of that point? So my answer for focus would be 2.5, 0. The axis of symmetry is going to be the line that goes through the vertex and the focus. So in this case, my graph is going to be horizontal. So let us, this ruler sticks. There we go. It's going to be horizontal. So I'm drawing this horizontal line that goes through both of these. And it goes through the vertex and the focus. Now, is it going through the x-axis or the y-axis? We notice it goes through the y-axis. This is our axis of symmetry, by the way. So we're going to say y equals 0 is our axis of symmetry. The directrix has to be vertical. So let me write this vertical. And we do the opposite of what we did with the focus. So instead of right 2.5, we're going to go left 2.5. So from the vertex, I'm going to go 1, 2.5. And I'm going to draw a vertical line because it has to be perpendicular to my axis of symmetry. So here is my directrix. So let's put a DIR, and it is going through the x-axis at not 2.5, at negative 2.5. Again, let me highlight here. Let's use pink here. You are using, this is my main answer right here. This is my main answer. This is my main answer. And this one. And of course our p-value. Okay, now the last thing we need to do is find our 2 points. We need our 2 points. So 2 points means we have to calculate 2 times p, which in this case is going to be 2 times 2.5. And 2 times 2.5 is a distance of 5. Now remember that I told you that our graph is supposed to be facing to the right from our vertex. So that means it's going to go like this somehow, okay? So we need to know how wide, because we don't know if it's that wide or if it's going to be this wide or if it's going to be really, really skinny. We don't know. So we need 2 points to help establish the width. So from our focus, I need to go a distance of 5. So I'm going to go up 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And now from the vertex, when you draw your curve, you always go from the vertex towards your focus. From the vertex towards your focus. And there is your right-facing parabola. Okay, so for the last bit, here is the general form of a conic. So write this down first. Now, when you write this down, don't think by any means that you're going to have to do any memorizing of this, but just follow me along here for a second. Okay. All right, so this is what we call the general form of a conic. So many times a conic will not be given in standard form, as you have been seeing in the examples for all the conics that we have covered in this unit. Sometimes they'll give it to us in general form. And when they give it to us in general form, it is a lot more difficult to decipher what conic it is. So we have here in this little chart a system we can use to help us determine or classify a general form of a conic as being a circle, a parabola, ellipse, or a hyperbola. And so what I want you guys to notice is that in this chart, all we are interested is finding the values of A and C. So if you look at the equation you just wrote, your A is the coefficient of your x squared, and the C is the coefficient of your y squared. So those are the two values that we're looking for. Everything else, negligible. We don't need to be concerned about that. So here's how you will do this. And this example 5 is an example of what's going to be on our test as well, by the way. You will have this classification to do on the test. So you are going to look for the value of A and for the value of C. The value of A, again, was the coefficient of my x squared, which is right here, and the coefficient of my y squared, which is right here. Those numbers are the numbers 1 and positive 4. So we look at the first rule. Are A and C equal? No, they're not equal, so I'm going to cross that out as an option. Then I'm going to look at parabola. Is A times C going to give me a 0? Well, 1 times 4 is definitely not going to be a 0, so parabola is not an option. If I multiply A times C, is it going to be greater than 0? Well, 1 times 4 is 4. 4 is greater than 0. So I can say since A times C equals 4 and it's greater than 0, therefore it's going to be an ellipse. Those 3 dots mean therefore. Okay, so let's repeat the system. I want you to work out problems B, C, and D. Pause this video, do that, and then unpause the video and let's see what you got. Okay, so let's go do these problems together. So you found A and you found C. In this situation, your A was a positive 1 and your C here was also a positive 1. When we when we check to see if A is equal to C, they are equal to one another. So A is equal to C. Therefore, it's going to be a circle because they were both equal to 1. On this next situation, our A value is going to be the negative 2 because it's in front of the x squared. Our C value is going to be the positive 4. Well, we know it's not equal to one another. They do not multiply to give 0. When we multiply A times C, we get negative 8, and negative 8 is definitely not greater than 0. So it's our last option. -8 is less than 0. Therefore, our classification, if we were to graph this general conic of a form, you would graph a hyperbola. Last but not least, we are looking for A and C. Well, when I go look for A is my x squared term, and I look and I do not see any x squared term. So when I don't see an x squared term, I can say my A is 0. As far as C, hold on a second. As far as C goes, C is the coefficient of y squared. That's a 2. And we notice right off the bat of our answer choices, they're not equal to each other, but we do notice that if we were to multiply A times C, that would be 0 times 2, which gives me a 0. Therefore, my answer for classification is parabola. And that's it, my dears. That is section 8.3 over parabolas. Hope this helps you get through your homework. Thanks for watching.